Meantime, startup Databricks announcing some key milestones today, including a $4 billion revenue run rate in Q2. That's up 50% year over year. Its AI products crossing above $1 billion in revenue run rate as well. Plus, the company closing a fresh round of funding, $1 billion worth of funding at a valuation of more than $100 billion.
Let's roll back to the late 2000s. At UC Berkeley, a group of researchers in the AMPLab were trying to solve a big problem: how to process enormous amounts of data faster and more flexibly than existing tools allowed. At the time, the go-to system for big data was Hadoop, an open source framework that stored and processed massive data sets across clusters of cheap commodity servers. It was revolutionary in the early 2000s, giving us a way to crunch data at scale through its Hadoop distributed file system and map-reduced parallel programming model. However, Hadoop was built mainly for batch processing, relied heavily on reading and writing to disk, and was limited by the structure required for the map-reduced programming model, making it unsuitable for complex unstructured data types and too slow for real-time or interactive analytics. Meet Matai Zaharia from UC Berkeley's AMPLab, who was dedicated to resolving these large-scale and real-time data processing limitations. In 2009, he started building a framework called Apache Spark. He was later joined by Ali, Ion, Reynold, Andy, Arslan, and Patrick, who helped Spark flip the script on traditional data processing jobs. By running computations in memory instead of constantly hitting the disk, it made data processing up to 100 times faster in some cases. It also expanded beyond batch jobs, supporting streaming data, machine learning, and analytics. By the time Spark matured, it was already being used by heavyweights like NASA, Amazon, Netflix, and eBay to process massive datasets, improve efficiency, and run large-scale analytics. In 2013, the team donated the Spark project to the Apache Software Foundation, where it became a top-level Apache project, ensuring it would stay open-source and community-driven. After open-sourcing Spark, the same group of researchers, Matai, Ali, Ion, Reynold, Andy, Arslan, and Patrick, saw an opportunity. They realized that while Spark had transformed how data was processed, many companies still struggled to actually implement it. Deploying and scaling Spark required deep technical expertise, complex infrastructure, and a lot of patience. So, in 2013, the team founded Databricks, a company built to make data, analytics, and AI accessible for everyone, not just the data engineers who could wrangle Spark at the command line. Their mission was simple: take everything powerful about Apache Spark and package it into a platform that can handle every stage of the data journey, from raw ingestion to structuring, governance, analytics, machine learning, and AI, all in one unified environment. To understand what made Databricks revolutionary, we have to look at how messy enterprise data had become. Most organizations were juggling two types of systems: data lakes and data warehouses. Data lakes were the Wild West, flexible, scalable, and cheap to store massive amounts of unstructured data, but they lacked reliability, governance, and they were notoriously difficult to query efficiently. Data warehouses were the opposite: structured, consistent, and great for analytics, but rigid, expensive, and not built for scale and the diversity of modern data. Databricks introduced something new, the Data Lakehouse. It combined the best of both worlds, the flexibility and scalability of data lakes with the reliability and performance of warehouses. In a lakehouse, data doesn't need to constantly move between systems. It can stay in one place and still be queried, analysed, and used for AI training, all in real time. This architecture gave companies a single unified platform to manage everything, from streaming and batch data pipelines to analytics dashboards and machine learning models. It made working with data dynamic, efficient, and collaborative, exactly what modern businesses needed. This leads us to the AI wave and Databricks' big moment. As the world shifted towards artificial intelligence, the need for robust data infrastructure exploded. AI systems are only as good as the data they're trained on, and most organizations were sitting on mountains of untapped and often unstructured information. That's where Databricks found its sweet spot. Its platform became the bridge between raw data and intelligent systems. Data scientists, machine learning engineers, and analysts could all work together in a shared space, building, training, monitoring, and deploying AI models at scale. The company had also doubled down on open source, developing Delta Lake to bring reliability, consistency, and transparency to data lakes, providing an open source data lakehouse alternative, and MLflow, a platform for tracking, managing, and deploying machine learning models. Both were released to the open source community to encourage collaboration, research, and innovation. Together they form the foundation for what Databricks now calls the Data and AI Company. In the age of generative AI, the positioning couldn't have been better timed. Companies now need infrastructure that can handle massive data workloads and support AI workflows seamlessly, and Databricks is right at the center of that ecosystem. Databricks is now used by more than 60% of the companies on the S&P 500, powering data and AI solutions for some of the biggest names in the world, including Apple, MasterCard, McDonald's, DoorDash, BP, Capital One, Heineken, AT&T, JP Morgan, and even Minecraft, which reported a 66% reduction in processing time after adopting the platform. From an academic project to a $100 billion enterprise, Databricks is proof that innovation doesn't stop at the research lab, it scales, commercializes, and eventually, it reshapes entire industries. If you've enjoyed the video today, make sure to subscribe and like, as this is my first video and to really support the channel.